Experiment 8 is a qualitative testing lab similar to one that we did before. We'll be practicing with using blanks, as well as positive and negative standards, and we'll be identifying an unknown using 4 new qualitative tests. 2 flame tests, 1 acid-base test, and 1 solubility or precipitation test. In this experiment, we'll be using a number of different reagents, and you'll be looking up the safety information for several of them as part of your PreLab assignment. Some of the reagents that we'll be using are not covered under WHMIS regulations, things like sodium chloride or potassium chloride. And many of these materials that aren't WHMIS regulated are going to have similar types of hazards, where they can cause skin or eye irritation and are not particularly toxic. We'll also be using a number of unknowns for testing, and some or all of these will be mildly toxic if ingested, and some or all of them may be mildly acidic or cause skin or eye irritation or damage. So you should take general precautions. You should avoid contact with the skin or eyes, and you should flush thoroughly with lots of water if you make contact with these unknowns. A simple flame test can be used to identify the presence or absence of sodium ions or potassium ions in solution. And the process for performing one of these flame tests is exactly the same as the one that we saw before for the Beilstein test, with the one difference that this test can be done using any wire. We'll be using nichrome wire for our testing purposes because its melting point is extremely high. You start by placing the tip of the wire into the flame. You heat it until the flame color stabilizes. You then remove the wire from the flame and allow it to cool. You then dip your wire into your test solution and then place the wire back into the flame and observe the color change, if any. At this point, you should rinse off your wire with distilled water, ensure that it's fully clean, and then you can move on to test your next sample. The data tables for this section of your experiment might look complicated. There are 4 of them, which seems like a lot. But really, only the final data table is important for your report. The first 3 data tables are more for practice, because as we saw in the last qualitative testing experiment, flame tests are difficult, they're finicky. And in the case of the group 1 metal ion flame tests, the risk of contamination is extremely high. The problem is that sodium ions produce an intense yellow flame that can easily overwhelm the much more faint purple color that potassium ions produce. So the first 3 data tables are really designed to make you practice testing for sodium ions, testing for potassium ions, and then testing for a mixed sample where you have both potassium and sodium present. For all of the flame tests, you'll be performing every single test twice. Once while simply looking at the flame to observe the color, and once while looking at the flame through a piece of cobalt blue glass, which is designed to block out the yellow from the sodium ions. You should find that all of your blanks and all of your negative controls produce no change in the flame color, while the sodium ions produce a bright yellow color, and the potassium ions produce a purple or violet color. In the mixed sample, you might think that you would see both colors, but in fact, the yellow is so bright that it overwhelms the purple entirely, and all you see is yellow. Once you've done these tests, you can repeat them using the cobalt blue glass. And ideally, for the blanks and negative controls, again, you're going to see no change happening. This might look a little bit different from when you did it without the glass, but what you see will consistently be representing a no change situation. Remember that the cobalt blue glass is designed to block yellow light. So when you run the positive sodium control, you might expect to see a yellow flame, but hopefully that color is blocked by the blue glass and you see no change. When you run the positive potassium control using the blue glass, the color that you see won't be the same purple as without the glass, but it should still look fairly reddish, and it should be distinct from what you see for the negatives and for the sodium positive control. And then, when you perform the test with the blue glass on the mixed sample of sodium and potassium, the sodium color should be blocked by the blue glass, and you should still see that reddish color that indicates the presence of the potassium ions. And at this point, you've done enough of the testing to fill out most of that final table. You can fill out the blank sodium and potassium chloride, as well as the ammonium chloride. The only thing left to do is to test your unknown both with the glass and without the glass. The next qualitative test that you'll be performing is an acid-base test for ammonium ions. All of these samples will be tested in the same way. You'll obtain a small beaker, and then you'll add approximately 1 milliliter of that sample to the beaker. You'll then obtain a piece of pH paper, and you'll moisten it with water, and you'll stick it onto the convex side of a watch glass. You'll then add approximately 2 milliliters of approximately 6 molar sodium hydroxide to your beaker. Then cover the beaker with the watch glass, making sure the convex side is facing down so that the pH paper is inside the container that you've built. And then wait a minute or two and see whether or not your indicator paper changes color, indicating the presence of an ammonium ion in your sample. As always, when you run this test, the blank and the negative control should give no change. The color of your pH paper should stay the same. The ammonium chloride solution, the positive control, should cause the pH paper to turn blue because ammonia, a base, was released as a gas. And your unknown may or may not change color. The final test to be performed in this lab is a precipitation test that looks for the presence of chloride ions in solution. You'll be running this test twice. The first time, you'll be running the test in such a way that you're going to see the presence of a number of false positives. The first thing to do is add a small amount, half a milliliter to a milliliter, of your sample to a test tube. Then add a few drops, 1 or 2 drops, of silver ions in the form of a dilute silver nitrate solution to that test tube, and observe for the presence or absence of a precipitate. As always, you should see no change for your blank, that is, nothing will precipitate. But for the sodium chloride, sodium hydroxide, and sodium carbonate samples, you should see a solid precipitate in each of those cases. And this indicates that hydroxide ions and carbonate ions can cause false positives in this test, and we need to get rid of them, at least if we want the test to be effective. You'll then run the test again. You'll start with a blank tube and you'll add a small portion of your sample to it. This time, you're going to add an excess, so about 5 drops, of moderately concentrated strong acid to the test tube. We'll be using nitric acid. And this should eliminate the hydroxide ion and the carbonate ion from the solution. At that point, you'll add your 1 or 2 drops of test reagent. So again, the silver nitrate solution. And at that point, you can observe for a precipitate. Of course, you should see no change for the blank, but this time you should also see no change for the sodium hydroxide and sodium carbonate samples, because the acid should have converted the hydroxide to water and the carbonate to carbonic acid. You should see a solid precipitate for the positive control, the sodium chloride. And of course, your unknown may or may not produce a precipitate.